So, hello everyone. This is Georgios from University of Patras. Today I will present to you OpenSlice, which is a service-based OSS, and how it can be used towards intent-based network management. So this is the presentation agenda. So what is OpenSlice? OpenSlice is an open source service-based OSS which its scope is to deliver network as a service following the main SDO's standards, like ETSI, TM Forum, GSMA, and 3GPP. It was developed in the scope of EU project 5GPINI and has been adopted and received contribution from several other projects and organizations moving on. It complements other future network activities and facilitates prototyping and experimentation. So what OpenSlice does? It exposes TM Forum open APIs and interacts with NFVOs in a way that it makes it interoperable with ETSIs, MANO, OSM. Moreover, network slices are described according to GSMA GST, generic slice template, and it exposes the GST to the TM Forum Network as a Service suite. So, as I said before, OpenSlice is a service-based software where when a third party wants to access what it offers, can do it via three ways. One way is if you want a network as a service, you will follow the classic NFV approach. For the NFV approach, we have a web portal, the NFV portal, that you access it, and then it is interconnected with the NFV management API service, and through the message bus, you can communicate with external NFVOs that orchestrate your network. The other approach is a more generic one and not so network domain specific. It's through TMF APIs. The TMF APIs play the role of operate APIs. And we have 4 different portals, giving more gravity to the services and resources portal. The third party can connect via these portals, these web UIs, which communicate with the relatively full suite of TMF APIs that then can offer you either Kubernetes resource definitions as a service. This is something new that we added, and it gives great flexibility to the orchestration abilities of OpenSlice, or other BSS orchestrators. All the orchestration inside OpenSlice is done via Awesome, the service order and service orchestration. I forgot to mention that in the TMF way, you can also access it via TMF APIs, which make it interoperable with other OSS systems that support TMF, which is relatively standard in the telecom world. So these are the examples of the portals that I just said, and more connection between them. So using one way doesn't exclude the other. And for example, from the services portal, you can access the services and or design the services, depending on what credentials you have. And in the NFV portal, you can find end-on-board artifacts from external NFVOs. So as I said before, OpenSlice offers Kubernetes custom resource definitions as a service. In order to do that, we wrap the Kubernetes APIs, we wrap them with TMF APIs, which enable loose coupling between orchestration scenarios. This helps developers to have a relatively more easy learning curve in order to use OpenSlice, as they will use technologies and languages that they already know. So a developer can write a CRD with its associated controller in any language that you want, group it into CRD, and then deploy it via OpenSlice. Moreover, a developer is able to use whatever tool is already available online, and there is a large library of tools online. After the CRD is created and deployed into the Kubernetes cluster, is exposed in the service catalog of OpenSlice. But you say, what is the service catalog? Sorry, the time is relatively small and the presentation is too big. But the service catalog is where the service specifications reside. We have two different kinds of service specification: the customer-facing services specification and the resource-facing service specifications. The resource-facing service specifications now are references to other resource specifications, which in turn, they can be references to Kubernetes custom resource definitions, or they can be network slice descriptors references, which brings us back to the good old NFV world. When we choose the TMF world, let's close the NFV world. From here, we go to an external NFVO and the orchestration is done. When we choose the TMF way, now we go into our internal orchestrator also, which communicates with the cluster below and creates a running service. The running service can be a single service on its own, which communicates with a single resource, or can be a bundle of services, which can become pretty complex. You can go on and on. So these are the UIs I just told you about. Here you can see the services catalog, where you can simply go and order a service, then the admin will accept it, and the service will move on to be instantiated. And here you can see the NFV portal. In the services catalog, the TMF web UI, when you have the appropriate credentials, you can also design your own service here and choose the different characteristics of the generic slice template that you want to add to your own service. Moreover, OpenSlice offers a lifecycle management tool, which is created by 5 different types of rules. So the service designer can create rules in each state of the service in order to control it and manage it. These rules are created only through the OpenSlice portal with Blockly. Blockly is a tool that Google created mainly for STEM, and we took it and translated it into Java. Practically, we have created some blocks of natural language where the developer doesn't have to write a real code. He just describes what he wants, and then we create the rule. These rules are actually just runtime Java language injection to the runtime code. So why I tell you all about OpenSlice? OpenSlice is an OSS, an operations support system. But where are these systems used? These systems used in the network slice as a service model of 3GPP. In order to understand this journey, we have to start from the beginning, the generic slice template, or GST. GST was created by GSMA, and it is a set of characteristics that are generic to the use case, to the slice type, and whatever the network slice provider and the network slice customer have agreed between them. So we have a generic set of characteristics which has to be filled with its use case values. When it is filled with values, we create a network slice type of nest. Different SDOs have designed different nests, which are called standard nests. And these are the slices known to most of us, like and UoP, URLC, etc. So moving on, the network slice providers take the standard nests and enrich them with their own values in order to create private nests. By combining standard and private nests, they create their product offerings. Then the network slice customer comes and creates an order. This order goes to the provider's BSS, and then the provider BSS sends it back to the provider OSS, and the provider OSS creates the slice that was needed. But you can see here that the GSMA GST actually is a coupling of natural language with network values. And there we find a problem. Not the problem, an opportunity. The opportunity was the LLMs, generative AI. We thought that if there is already a coupling between natural language and values, why cannot a customer order it in a more automated way? So we created, we thought about intent-based network management on this level. First of all, we have to define what is intent. Intent is operational objectives expected from the network, which are introduced in a declarative manner without specifying the implementation details. Right now, contemporary networks are required to comprehend and facilitate the emerging needs of various verticals. The deployment and reconfiguration needs to be dynamic. So we have network as a service and network slice as a service. Network as a service can only be implemented by end-to-end orchestratable solutions, like the solution that OpenSlice offers. And there need to be several standards in place in order to make it more simple and interoperable with different OSS and BSS systems. However, a simple customer doesn't care about either standards or orchestration. He just wants to make it work. So the users seek advanced services disregarding network intricacies. And here we found a gap for generative AI. What we propose is a simple dialog block, where in this block there is an essential keywords analysis. Then the LLM takes what is here and gives back a nest. Then the user can tweak the nest by asking the LLM several other questions. After this is finished, the final nest is ready to be translated into an operate API, in this case, TMF APIs. And then the OSS will send it to, after the admin validates it, will send it to the infrastructure to be deployed and instantiated. How are we time? In order to achieve that, we did some few-shot learning. The few-shot learning that we did required that we get from the most spot-on questions to more generic ones and label them with their associated standard nest, S-nest. And initially, the first question of the customer acts more like a classifier where a standard nest returns back to the customer. And then when we enabled the chat box with generative AI, the nest stopped being static and standard and could be more dynamic and more tailored to the customer's needs. And after that, the nest here is translated to TMF service order and can be instantiated via OpenSlice. Here we have a demo. Let me see. So this demo is a proof of concept. So here you can see that first we ask what slices do we want to order. It's not, of course, required.
George,
Yeah?
sorry, it's Mary. Would you mind sharing the screen?
Oh, yes, of course, Mary.
I was following the presentations online, but it makes more sense if you share the screen.
Give me 1 second. We are through the web UI, Nikki.
Or go on just on the browser window and then
Here?
no. On the taskbar. If you go on the taskbar to the Chrome symbol and then share this little button on the bottom of the mouse.
Okay. So
No, you are on the right.
on the right?
Yeah, and then to the right.
Share this window?
No, to the right.
This window.
This one, yeah.
Okay.
Yeah.
Marin, can you see now?
Yes, perfect. Thank you.
Okay. Yeah. So here is a proof of concept of what we've done. First of all, we describe our scenario. We get a first nest. Moving on, we tweak it with more questions. Sorry to skip it, but we'll have to save some time. And after we agree to a specific nest, it is forwarded to OpenSlice, then the admin accepts it. Here is when they accept, it is acknowledged, the service order. And we will see now that it will say completed in a few seconds. Okay, here is a graph of the different services that were used for this service. So this is a bundle of services actually, in order to create a 5GS service with the specific network configuration or slice. Okay, moving on. In this proof of concept, initially we used text-based intent. The dialog was done through CLI. Okay, CLI, then we moved on. We created local LLM with Olama. In the future, we want to add multimodal support and fine-tune our model. Anyone who wants more information about OpenSlice, they can find it here. The presentation is uploaded. Thank you all, sorry. Any questions?
No, you're good, thanks.
I have a question.
Question?
First of all, thanks so much for the presentation. I think that's what we're talking about dispatching or particular requests for the allocation of resources like into locations. And I want to ask you, what kind of allocation strategies do you guys use?
So the allocation strategy of resources initially is what the external orchestrators offer. We mainly use Kubernetes and NFVOs, so they have their own algorithms, and we cannot believe that we can beat Kubernetes right now. We try to make it, we try to use generic tools, standard tools, because there is a great support behind them. And for now, before we manage to create a good assurance tool, we don't want to get into the allocation part, the resource allocation. When we are okay with what we've done with assurance, we will move to the allocation.
Just quickly bringing it back to AI, right? So there's a lot of AI on machine learning on how to optimize the management of slices, right? And then, but then also, I guess, really, if we're doing some sort of application, you want to run the AI algorithm, machine learning within a slice, right? So how do you see AI fitting into this picture here and using OpenSlice?
Well, AI in OpenSlice right now is not something that we have already discussed. It can be placed in different parts of the architecture actually, from the orchestrator to the resource allocation. But give me 1 second to go back to the architecture page. So actually, AI in OpenSlice can be implemented in different parts, but we would prefer AI to be outside of OpenSlice in order to keep it as white box as possible. And we can support many AI applications if they are Kubernetes compatible. But in this architecture right now, we would prefer to keep it clean in order to be as user-friendly as possible and as white box as possible in order to make it research-friendly. And we can quantize the results that we get, if that makes sense.
I guess I wasn't thinking of adding AI to the architecture, but more that where should a 6G DMI controller fit into the architecture? Right?
Well, the DMI controller could be actually be a CRD, service ordered through the service portal. And it could be on demand. We have already a 5G as a service. And we could add as a bundle the DMI controller on this specific. So we would create a new service bundle where the DMI would be a part of the bundle services. If that makes sense.
Yeah, very good.